Hello ladies and gentlemen, welcome to my video. This is the question we would like to solve today. Integrations of inverse tangent functions. Because the integration bound is not symmetry, it takes a little bit longer to solve it, even though with some experience, you already know what is the answer. First thing to do is to make sure the integration bounds become symmetry. How do we do that? We can define a u equals to x minus 1 over 2. And then du equals to dx. When x equals to 1, u equals to 1 over 2. When x equals to 0, u equals to negative 1 over 2. Meanwhile, we know x is equals to u plus 1 over 2. Therefore, 1 minus 2x become 1 minus 2 multiply u plus 1 over 2, which is negative 2u. 1 plus x minus x squared equals to 1 plus u plus 1 over 2 minus u plus 1 over 2 power 2, which is equals to 5 divided by 4 minus u squared. From here, we obtain the new q equals to integral negative 1 over 2 to positive 1 over 2 inverse tangent of negative 2u divided by 5 over 4 minus u squared and then du. This is better because integration bound is symmetry. Let's say fx equals to inverse tangent x. We know that f negative x is equals to negative inverse tangent x, which means fx is a odd function. Calculus rules 101. Integral negative a to positive a for a function fx when fx is odd function is equal to 0, which means our answer for this question is equal to 0. This is a solution by definitions. If you would like to know the solution by derivation, there are two ways. Number one, solve the equation q using many rounds of integration by parts and partial fractions. Number two, continue watch this video for another minute. First, label this as equation 1. Define t equals to negative u, therefore dt equals to negative du. When u equals to 1 over 2, t is negative 1 over 2. When u is negative 1 over 2, t is 1 over 2. Q become integral positive 1 over 2 to negative 1 over 2. Inverse tangent function of 2t divided by 5 over 4 minus t squared and then multiply negative dt. Two things we can improve equation q. First, we can solve the integration bound by cancelling the negative dt become positive dt. Second, we know inverse tangent is an odd function, so we change 2t become negative 2t, but we add the negative sign in front of the inverse tangent. Label this as equation 2. And then we copy the previous equation 1, put it here side by side with the equation 2. Both equations look similar, one in u, one in t, but doesn't matter. T or u are just dummy variable. Here we can change the equation 2 from t become u. Apply equation 1 plus equation 2. We have 2q equals to 0. So conclusion of this video, final answer of this question is equals to 0. Thank you for watching my video until the end. Please continue support my channel, subscribe, give a like and share my video with others. See you tomorrow for new video. Bye bye.